Today our lesson is going to cover what we do when our triangles are overlapping with each other. So in the past, all of our triangles have been right side by side, sharing one side, but not actually covering each other up at all. We had some three-dimensional pictures where it kind of looked like they were covering each other up, but we could think about unfolding the three dimensions and laying them flat. So in today's lesson, there's not technically anything new. Because we've already learned all 8 of our congruence methods. There are only 8 ways to prove that triangles are congruent, and we've already learned all 8 of them. So there's not anything new according to that. It's just that our pictures are going to look different. These proofs might only be 2 steps, which is a little ridiculous to me because that means you're given everything you need and then you can just finish out the proof right away. So it's a little silly, but it might happen sometimes. To balance that out, some of these proofs will also end up being a little bit longer than we've had before. So for our first example, we're going to go ahead and start out with our given.
Yeah, you are.
A suggestion for you is that you work not only with the original given picture, and it's important to not totally just disregard that picture. Sometimes the original given picture is going to be very important to us, but to also draw yourself a picture of the 2 triangles separated. So I'm going to take those 2 triangles and slide them apart so that I can see separately triangle DEF and triangle XYZ. The reason why I like to do this is then when I mark up my congruent things, I'm going to do it into separate triangles so that I can tell for sure when I have marked 3 things, and then I can tell what those things are to be able to name the type of congruence. As opposed to if we do it in the overlapping picture, sometimes it's a little bit confusing about when we actually have what we need to have and what we have. So I can mark right angles. I can mark that EF and YZ are congruent, and I can mark angle E and angle Y. So I was able to make 3 markings, which is what we need to be able to say that triangles are congruent. So this one should be ready to go then, and this one is just 2 steps. We were given everything we need to be able to end out this proof. So then our job is to figure out why is it congruent, which one of our ways. So the first question I asked myself is, did I say anywhere in there right angles? Yes.
Yeah.
So I'm going to use a 2-letter name. Did I say anything about any other angles other than the right angle?
Yeah.
Yes. So I'm going to use an A. And then is the side that we labeled a hypotenuse or a leg? Hypotenuse. So my reason is going to be HA.
Oh, it's just 2 steps.
It's just 2 steps on this one because we were given all 3 pieces of congruent information that we needed. So some of your problems tonight might only be 2 steps, but some of them will be longer to balance that out. Our second example, we'll go ahead and begin with our given. And drawing out our separated triangles to be able to mark up and see more easily when we have what we need. So I can't mark anything in my pictures for perpendicular, but I can mark DF and XZ, and I can mark angle E and angle Y. So I only have 2 markings in the picture, which means that I still need to make another marking. Our givens that we haven't used yet are perpendiculars. So what do perpendiculars tell us?
Right angles.
That we get right angles. So angle D and angle X are right angles because of those perpendiculars. So that is our definition of perpendicular. And then I can mark that. So now 3 things are marked in the triangles, which means that we should be ready to finish this out. And we have to determine y. So did we say right angle?
Mm-hmm.
Yes, so we're going to use 2 letters. Did we say anything about an angle other than the right angle?
Yes.
Yes, so we're going to use an A. Is the side that we labeled a leg or a hypotenuse?
An egg.
A leg. So our reason is going to be leg angle. Yes, question.
Read like the where you wrote like the reason for 2.
Definition of perpendicular. Okay. All right. Go ahead and start out with our given again.
We're doing the same exact things that we've been doing, just different pictures.
Yeah, the same 8 reasons are applicable. It's just that our picture's overlapping. And those last 2, we were able to just completely separate it out and start marking them up. And this one, it's going to be important that we look at our overlapping picture as well to get some information. So this one's going to be a longer proof for us. Last 2 were pretty short. This one's going to be a longer one. I do still like to draw my separated triangles. I draw those out every time so that I can mark up when I have congruent things and tell when I have 3 congruent things. So looking at my givens, EN and YN are not in my separated triangles. So I can't mark those in there, but I can mark them in the overlapping picture. That EN and YN, where is it? That doesn't, oh, I marked the wrong thing. There we go. EN and YN are equal. Then NF and NZ, again, are not in our separated picture, but I can mark NF and NZ down in the full picture. Angle D is the same as angle X. Those I can mark up in the original picture, or the separated pictures. And E and Y I can mark in the separated pictures. So in our triangles we're trying to prove congruent, we have 2 things marked. We were able to make some other markings, but not in the 2 separated triangles. So that means we need one more thing to be congruent. If we look at our overlapping picture, we can see our goal is going to be that diagonal side, because that's where our other markings are. But so far, we can't say that those whole diagonal sides are equal. So that's going to be our goal now. To do that, what we're going to do is take these 2 pieces of given information and combine them by adding together the left sides and setting that equal to adding together the right sides. So I'm just adding together the left sides and adding together the right sides. Our reason on that is addition property of equality. It's like algebra. We're just taking and like adding 2 to both sides of something. We're adding together 2 equations. A lot of students want to call it segment addition. In segment addition, we should be taking 2 segments and putting them together to make one thing, which is not what's happening here. Okay? In segment addition, we want to be taking 2 individual segments and putting them together to make one segment. In a segment addition, you'll have to be looking at a picture to be able to do that. Whereas this, I didn't even really need the picture. I just took the 2 pieces from the given and added them together. Okay? So that's just an addition property. Segment addition is going to be important to us, though, because if I look at the picture, I can see that EN plus NF actually means something. it makes EF. And likewise, YN plus NZ combined together will make YZ. And that's segment addition. So segment addition is when we use our picture to combine two pieces and make one bigger piece. Regular addition is just combining two equations together. Now we just said a lot of the same stuff in steps 2 and 3. We said EN and NF in both of them, but we gave that a new name. Then we said YN and NZ in both of them, but we gave that a new name. So when we have this much stuff that's matching up, we should be able to match up the rest of the stuff and say that EF is equal to YZ. What is that called? Substitution. Because we had some other things that were equal, we could set together equal some new things. And now if we look at our separated picture, EF and YZ are there. So now I can mark those in our separated picture, and now I have 3 things marked, which is the goal. So now I can say my triangles are congruent. And I have to think about a reason. So first question I ask myself is, did I say right angle? No. So we're going to use a 3-letter reason. So then I ask myself, how many angles do I know? 2. So I'm going to need 2 A's, and then I have to decide, where does the S go? Is the side directly connecting the 2 angles together, or is it somewhere else? It's somewhere else. So this is going to be AAS. The side is not directly connecting the angles so that S doesn't belong between the A's. Okay? If the side is a connector, then it's ASA. Questions? One more. As a heads up, this is going to be 7 steps. So if you tend to write large, you might want to write small. And I do suggest that you write it out and take a note. In your homework, your longest group is going to be 6 steps, but it's going to be pretty similar to the last one and this one. So if you have something to look at and remind yourself how those work, that might make those problems a little bit easier for you. So we'll go ahead and begin with our given. And I also like to begin by separating out my triangles. Okay, marking for the givens, I can't mark perpendiculars. DZ and XF are not a part of the separated triangles, so those have to be marked down in the original picture. Angle E and angle Y are a part of the separated triangles, so I can mark those up in my separated picture. So I only have one thing marked in those triangles, so we've got a little bit of work to do because we have to get to having 3 things marked. So the first piece of the given that I haven't been able to mark up is something about perpendiculars. What do perpendiculars tell us? Right angles. So angle D and angle X are right angles. Definition of perpendicular. And then I can mark that. So now I have 2 things marked up. We need 3 things marked up. As a hint for what our third thing should be, it should have something to do with what we were given. So looking at the original picture, we were given some information about the bottom sides. but not the full bottom sides, and that's what we need. We need to be able to say that DF and XZ are congruent, the full bottoms. So, what do they have in common?
GF.
That middle piece. So what I'm going to do is say that ZF is equal to FZ. I put it kind of over far strategically. I wanted to line it right up under the other given that this is talking about. You don't have to do that. It's just something I like to do, kind of like in algebra, how when I solve an equation, I like to keep all my equal signs lined up. So I'm lining that up with the other piece of information that we're hoping to build on. That's a reflexive, because we're saying something equals itself, even though I said the letters backwards. So now what we're going to do is use that given piece of information in this reflexive and do some algebra on them. We're going to add them together and say dz plus zf equals xf plus fz. Is that addition or is it segment addition?
Addition.
It's just our addition property. Because I didn't need a picture to do that, I'm just adding two equations together, kind of like in algebra, adding 2 to both sides of an equation, or adding 4 to both sides of an equation. I'm adding ZF to both sides of an equation. But now if we go back and look at our picture, these things probably have meaning. What is DZ plus ZF?
GF.
DF. And what is XF plus FZ? XZ. What's that called?
Segment addition.
That's segment addition.
Did we have to do 4 there?
Yes.
Stop.
I mean, you don't have to do step 4 as step 4, but step 4 has to be in your proof. It could be your step 5, but at some point you have to say that. And the reason why step 4 is important because now we're going to combine our information in steps 4 and step 5 together. Because we said a lot of the same stuff. We said DZ and ZF both times, but we gave it a new name. And we said XF and FZ both times, but we gave it a new name. So those new names should be equal. DF should be equal to XZ, and what is that called? Substitution. We look at our separated pictures now. DF and XZ are things that we can mark. So we're finally able to get ourselves to having 3 things marked, which means that we can now finally say that our triangles are congruent. And then we have to determine our reason. So did I say right angle? Yes. So we're going to use 2 letters. Did I say something about another angle?
Yes.
Yes. So we're going to use an A is the side, an H or an L.
Oh,
That was 7 steps. Your longest one in your assignment will be 6 steps, but it's going to be very similar to this one and the one before, where you're going to have to do those additions and those segment additions in there, okay, and substitutions. So I expect to see some of that. You will also have some shorter ones that are only 2 steps. Your homework tonight comes from worksheet H in your packet. So make sure you're looking at the right page. It's written in it was like a Sharpie. So it actually kind of looks like an A. There is no worksheet A. So if it looks like an A to you, that's actually an H. It's on the same page as I. So make sure you're looking at the right set of problems there.